Hello, I am Pooja Saharan. My today's topic is backpatching in compiler design. What is backpatching? In order to know what is backpatching, firstly the prerequisites for the backpatching is to understand what is intermediate code generation and what is three address code. Intermediate code generation is the fourth phase of compiler. Due to this phase, rather than producing the direct machine code, the compiler generated the intermediate code to achieve the platform independency. Now, the second one is the three address code. Three address code is an intermediate code that contains at most 3 operands. Take a simple example how to construct the three address code. Take an example of an assignment statement, that is X is A plus B plus C. Here we analyze that it contains more than 3 operands. So then we have take the temporary registers to divide it into the form of the 3 operands, that is T1 is A plus B, T2 is that contains T1 plus C, and X is T2. This is the 3 address code for this assignment statement. Now, how this 3 address code stored? It's stored in the form of the records, which have the fields, operators, operand 1, operand 2, and finally the result. For this, we have the array of the quadruples, that is 0, 1, 2, depend upon the respective statements of the 3 address code. Here the quadruple 0 represent this statement T1, where operator is plus and first operand is A and second operand is B, and finally the result stored in T1. The same procedure has to be followed for the other quadruples. Taken another example for the second statement of the 3 address code. Here the operator is plus. The first operand is T1 and the second operand is C, and the result going to be stored in T2. Hence, this is the way how we store the 3 address code in the form of the records. Now, after understanding these prerequisites for the backpatching, now we come to the topic of backpatching. What is backpatching? The activity of filling up unspecified labels. What are these unspecified labels? Firstly, take another example, that is M is greater than N, or O is less than P, and Q is greater than R. Now, take this is an 3 address code for this expression. Here we analyze this expression is an combination of mode operators, that is relational operators and the Boolean operators. Here we have 3 relational operators and 2 Boolean operators. Now, here the same problem arises that comes in this assignment statement, that we have more than 3 operands. So we required to resolve this problem using the temporary registers. For this expression, take a temporary register T1. And for this expression, the temporary register is T2. And for this expression, we have a temporary register T3. Okay. Now, till we have to be act on the relational operators. What about this Boolean operators? OR and AND. As we know, AND has the higher priority than OR operator. Hence, we act on T2 and T3 expression first. So, it will be resolved by taking a temporary register T4. And finally, the result for this expression is found by T1 or T4. Here, this is the 3 address code for this expression that contains the mode operators. Here we have the quadruples 10, 11, 12, 13, 14 and 15. Here the quadruple 10 represented that this T1 expressions gives the true value. When if this is true, then it go to the next quadruple. Now T1 gives, if this expression is not true, it gives false, that quadruple is that represented 11. Now next for this expression, the true value is at quadruple 12 and false value at quadruple 13. Now for the another expression Q greater than R, the true value is at 14 and false value at 15 for the 15th quadruple. Now here you analyze there are some unspecified labels. Hence, backpatching is now the activity to find these unspecified labels. For this, we have to do the syntax directed translation of a parse tree for this expression of the mode operators. First, see, these are the leaves for this parse tree. M, N, O, P, Q, R. M, N, O, P, Q, R. These are the leaves for this parse tree, and the internal nodes are the operators of this expression, that is greater than, less than, greater than, and or. These are the internal nodes of this parse tree. Now find it where it gets the true value. This expression gets the true value, and where it gets the false value. As for this expression, we already explained that it gives the 10 value at the, it gives the true value at the quadruple 10. Hence, this expression T1 gives the true value at the quadruple 10 and false value at the quadruple 11. Now, the same procedure has to be followed for the another expressions. This is the way why we analyze where we get the true value and where we get the false value for this relational operators. Now, as we know from this expression, after doing this relational operators, we have the Boolean operators. Here we already explained that AND has the higher priority than OR, so we act on the AND operator. Here, for this expressions T2 and T3, we have an AND operator. To understand how this AND operator acts, we firstly understand the truth table of an AND operator. That is, for T2 values, for T3 values, what is the result for AND operation? As we analyze from this truth table that for the T2 that is having the false values, always gives the false values for the AND operation, and if T2 has the one value, the AND operation must have to be depend upon the values of T3. Hence, here we analyze the term that is backpatch. It means whether there is a requirement to check the T3 expression for performing the AND operation. Hence, here we find that for T2, for the false values, there is no requirement to check T3. But for the true values, there is a requirement to check T3. Hence, backpatching is required. Backpatching is required for the T3 value when T2 have the true value. T2, now here from the parse tree, T2 has the true value at the quadruple 12. Now, what is backpatch with this 12? It is the next quadrant. It means after going through 12 and 13th quadruple, we have to be past the next quadrant, that is 14. Here we express the term that is backpatch. Means after passing the 12th, we must have to go to the 14th quadruple. Now, Now find what are the true and false values after performing the AND expression on T2 and T3. Merge the values of respective true values and respective false values. Here true values must be 12 and 14. But why not we write it here 12? Because 12 action is already specified that it has to go to the 14th quadruple. So here true value is at only 14. Now the false value is to merge the false values of T2 and T3, that is 13 and 15. 13 and 15. The same format or same procedure has to be followed when we performing for the OR operator. See how we do it. How the compiler judge when it has to act this process or do the backpatching. Here take T1 expression, and for T2 and T3 we have the temporary register, that is T4. T4. Here the AND operation is on T1 and T4. So the truth table for this OR operation is 0 0 0 1 1 0 1 1 gives 0 1 1 1. Here we analyze where the backpatching is required. The backpatching is required when T1 has the false value, because the result of the OR must have to be depend upon the T4 value. Hence backpatching is required when T1 has the false value. So T1 has the false value at the quadruple 11. Here we have the quadruple 11 for the backpatch activity. Hence what is the next quadrant that we have to be passed if there is a requirement of this T4 expression? That is the 12th quadrant. The next quadrant has to be passed if there is a backpatching for the 11th quadrant. Now merge the true and false values of the respective T1 expression and the T4 expression. Then here true value is 10 and true value is 14. We merge to get the 10 and 14. Now get the false values, that is the false value is at 11, 13 and 15. But here we mention 13 and 15 only. Why? Because here already 11 is backpatched with 12. There is no requirement to mention it here, because it always act for the false value and go to the quadruple 12. Now by analyzing this pass tree, we have to be fill this unspecified labels. How we find it? This is the backpatching, and we have the backpatching activity. What is the backpatching here? Backpatch, if there is a 12 quadruple, it must have to be go to the 14th quadruple. That is, for the 12th quadruple, you have to be go 14th quadruple. If there is an 11 quadruple, it has to be go to the 12th quadruple. Now this is the final 3 address code for this Boolean expression. Take an example to prove it. Is it giving the same result as we analyzed from our previous studies? Assume that this value is true. It means m is greater than 1. It means it's true. Now OR operation with this expression. Assume that its value is false. Take it 0. Now then AND operation with T3. Take it 1. As we know, the final result for this expression is 0 and 1 gives 0. 1 or 0 gives 1. It means, as we know from our previous studies, that it gives the result. So how we find it? From its 3 address code. Let's take it. M is greater than n. It gives the true value. It means for the true value, you have to go to the quadruple 10. For the quadruple 10, if m is greater than n, then go to nowhere. It means it itself giving the result that finally it's give the true value. Now you analyze what is the advantage to construct this 3 address code using the backpatching technique. That is, you reduce the jumps. Hence, it affects the time complexity and the space complexity. Now, what is the outcome for this topic of backpatching? Its outcome is now you have to be now you are able to construct the 3 address code for the expression that is having the mode operators, that is relational operators or Boolean operators. Thank you.